So today, I thought I would come up with something that I could teach you guys, and you guys can just watch. You can follow along. I'm going to make this project public, um, and so you guys will still have the code available to you. In fact, some of the code I've already built, and I just put in my backpack here, and so it's all ready to go. It's going to be really basic code for that. The other code, though, is going to be a little more complicated. And what I'm going to teach you guys today is I'm going to teach you how to create gravity in your games. So I was trying to come up with something for you guys and was having a hard time trying to decide what to create today. We have a lot of ideas. A lot of the other teachers have ideas. I didn't want to steal their ideas because they want to teach it too. And so I took a break and I went to my Switch and I started playing Super Smash Brothers. And one of the things I thought that was really interesting is that Smash Brothers, all the different characters actually have different fall speeds. So when you jump in the air and you start to come back down, you come back down at different speeds. But most of them jump at the same speed. So I started thinking, well, how could we create that? How can we do that? And that's what I'm going to show you guys today. So we're actually going to use a little bit of physics today. And I'm going to show you guys what the equation is. So most of you guys probably haven't seen this yet in school. Probably a lot of you haven't done physics, but every time we fall or we toss something up in the air, when we toss a ball up in the air and it comes back down, there's a bunch of variables being determined at any given time. It knows, the world, the universe knows where that is at, how fast it's moving, where its next position is going to be, and we can estimate this. So I'll show you guys the equation here, and I'll bring it over. So here's the equation that we're going to use. And this looks scary right now. One of the things we get to ignore is we get to ignore this right here. This is what's called an angle. We don't really care about the angle. We just want to know if it jumps up, how it comes back down. So we're going to use the rest of that for this. So curious, does anybody know what G stands for? I want to see if anybody has any ideas yet, if they've seen this equation. Just focus on the G here. Let's see, let's do a poll too. Yeah. Good job. All right, I'm not even going to do a poll. That is right. I was just in the middle of writing the poll and I got the answer. It is. It's our gravitational constant. And it doesn't have to be gravity. It's just an acceleration in general. But for now, we're going to use it as gravity. And that for us is negative 9.8 meters per second. But we're going to change that a little bit because we have a 1/2. And then we also have t. So t is time. And I'll show you guys how we're going to use time, because this is a little tricky, but Scratch lets us use a cool variable that they've actually created where we can use time to do certain things. And then we have this here, our v. Our v is our velocity. Now this is the speed, the strength in which we jump. So we're going to start with a high velocity by the end, and we're going to just filter it down to something kind of calm. So it jumps quick but falls slowly. And then right here, this final x that all of this is equal to, we're going to plug in an x into this, and this isn't the best equation. This is just an example of part of the equation. We do more math to get more variables. But we're going to find the final location where we land. So this is a cool little trick, and we're going to find it all along the way. So if we start at the bottom, our next location is going to go up, and then up, and then up. And once we hit the top, our next location is going to start coming down. So we're going to be able to use this science here to create a pretty cool jumping character. And feel free, if you have any questions, just post them. I can see the chat here. So don't hesitate to ask questions. I'm more than willing to answer because this is a big topic. Like once you start getting into this and trying to program this into games, there are studios that design game creation programs that have all this built in for us. Like you just go in and you say, I want to apply gravity to this character, and it does it. And there's a reason for that because this starts to get difficult. So I'm introducing a difficult topic to you guys, but we're going to do it in Scratch, which makes it a little bit easier to understand. I like Scratch because it can take really difficult topics and make them comfortable. So again, don't hesitate to ask questions. So let's get rid of this. And I'm going to go back to my character here. And if my mouse seems really wonky, I'm trying to get used to it. I just got a new one. And I don't know if you can see that. There's a huge delay on this. So yeah, you guys can kind of see that. So I got a new one. It's pretty awesome. It sits upright, but it is a little weird to get used to. And I haven't messed with Scratch much while using it. So I'm going to change the name of this to Gravity Demo. And I'm going to share it. And it's going to pop this out. Let's go back inside. First thing I'm going to do is I'm actually going to make my character a little bit smaller. And I'm going to set him down to negative 130. That's kind of where I want my baseline to be for him jumping around. All right, and then I am going to come in here and I'm going to grab my side to side. And I'm going to drag that in here so I can at least move them back and forth. I want to be able to do that. It's more fun to move them back and forth and jump around or it's more fun to jump around when you can move them back and forth. Let's set that off to the side. Let's zoom out. We want to get this out of the way. I don't want to use it. Not right now. Oh, it won't let me. Okay, that's fine. So the first thing I'm going to do is I need to decide what key I'm going to press. So I have A and D are going to be my side to side. When I'm playing games like this, I like to kind of use the standard, and the standard is the spacebar. A lot of games use the spacebar to move. So what I need to do is go into this is weird because my mouse is not set up on this account too, so I can't scroll normally. I'm going to go into events. And in events, I have when space key is pressed. I'm going to grab that and I'm going to drag that in. So this is going to be what lets us know that we're jumping up and down. I'm going to have the space key there. I could add it into here, into my forever loop here, where I'm already checking to see if the A key or the D key are pressed. I can do this too. I didn't want to do that because I want to separate this out so it's easy to understand. Okay, and then I need to create two variables. Oh my, and I was messing with it earlier, and it created way more variables in my demo that I was doing earlier. So the two variables I'm going to create, and I'm going to create it for this sprite only. I want this gravity to only impact this sprite. I don't want my gravity settings to impact any other sprite. So let's say that I wanted to go in and make Super Smash Bros. In here. You don't want player 2's gravity to impact player 1's gravity. So we want the gravity and the character that it chooses, which again, every character in Super Smash Bros. Falls a little bit differently. Like Samus falls really, really slow. I guess it's the spacesuit. I don't know. So we don't want our gravity to impact anybody else. A lot of times we'll do for all sprites. We do that a lot with variables, but not this time. The first one I'm going to create is called next location. When I do this, and it's all one word, even though it's two words, I just crunch them together, but I capitalize the first letter of each word. That's called camel case, in case anybody is curious. And did that create my variable? Let's see. It was next location that I wanted. Seems a bit buggy today. Okay, we'll save now and just refresh the page. It's alright, it happens. It's brand new. There we go. Now we got it back. That's cool. Not a big deal. Okay. So I have that first variable created. The next variable I'm going to create is called current velocity. All right, you made it too. Good. I'm glad you got that made. And I'm trying to record this Twitch. I'm still trying to figure out how to record things. So if I'm going a little bit fast, it's because I'm hoping that if I've done this right, it is recording right now, and that it will save it. So you guys can go back and look at it. And the way I have it set up right now is it will save for 14 days. So if I'm going a little bit fast, it's because I have faith in Twitch that I had the settings right today. The last one we tried only saved 30-second videos. It was kind of disappointing. I don't know why it did that, but I'm hoping this time we did better. Okay. There we go. So I have current velocity and next location. I want to turn these on. I want to be able to see these. It'll teach us a lot about what's going on. And that's going to be important, I think. There was another one I had that isn't really important, but we can actually change. We can also look at the velocity at any point we're at. So there's current velocity isn't. We're going to do something with current velocity that changes it. But there's another one that can actually tell you the velocity, how you're supposed to be at what given point, and so on and so forth. It's pretty cool. It's just another equation, but I'm not going to bore you guys with that. All right, and the next one, we're going to make a block. So we go to My Blocks, and in My Blocks, I am going to make a block called Gravity. So when we click on Make a Block, we get to name it. And then we have some options down here. These options are pretty cool. I'm going to add an input, number, text. These are all going to be numbers that we put in here. The first one is going to be time. I'm going to add another one. The next one is going to be position. And I'm going to add one more, and that will be velocity. All right. So time, position, and velocity. We want this to look exactly like this. And we want them all to be a input, a number or a text. We don't want Boolean. We don't want a label, just the input. And this is what our equation is going to require. So I'm going to create that. It's going to give us this little pink block here. This is pretty cool. Now what's neat about this pink block is we created this. And one, it shows us what our block would look like over here. So if we're not in there, we still know what our gravity block looks like if we go to My Blocks. But we also have the ability, see it has that hand, the hand icon. We can take this position, and we can grab it and drag it out. And whatever number we put in here, we can collect it from the function. This is pretty neat. I like creating blocks. These are called, in regular programming, we call these functions. So we're creating a function right now, and the function we created was gravity. And we can't quite output from a function, but we can save to a variable, and that's why we created those other variables. All right. Let's build let's see, what order do I want to do this in? All right. So I'm going to show you how the gravity normally looks. I think that's important. I think we should review that. So what I'm going to do is go to variables, and I'm going to grab the set variable and drag that in. And I'm going to change the type of variable to next location. I'm going to do our function here. That equation that I showed you earlier, I'm going to build that equation in Scratch, and I'm going to input it in here so that we take the variables that our gravity function is given, we put them through the equation, and then we're going to save it to next location. And how we do this is first we need to build our gravity by time squared. So we go to operators, and we're going to take out two of these multiplication operators. And we're going to drop one inside the other here. Now, this first one that's on the inside, this is going to be our time squared. One sec here. Excuse me, I wanted to mute the mic so I didn't cough into your guys' ears. I hope that didn't come through. All right, so this is going to be time squared. And time squared is just time multiplied by time. So we're going to take time up here in our gravity equation, and we can drag it in. We're going to drop it twice in this multiplication. So that gives us time squared. Now, you guys probably don't remember the equation, not off the top of your heads. I don't expect you to, but it was 1/2 times gravity. Now, gravity is negative 9.8 meters per second. So what we're going to do is we're going to take half of that, and half of 9.8 is negative 4.9. So this was our very last half of the equation. This was all the way on the right. This was 1/2 gravity times time squared. And again, we're going to ignore the angles and the cosine. We don't care about angles. We just want to go up and down. Like it'll arc. It'll show a cool arc. If you're moving side to side, it'll arc. That's what the blocks are that I pulled in earlier. Okay. Now the next thing we want to do is we want to create the left half of the equation, or in our case, it's actually going to be the center half. I only showed you guys a small portion of it. If you took another, it's called an integral of that, you would actually get 3 sections instead of just 2 sections. That's some calculus. We're not going to do calculus today, but we're going to do velocity by time. So we're going to pull out a multiplication again, and we're going to do velocity, which is the speed that something's moving, by time. Technically, velocity is speed and direction, but we're not worrying about direction. Now we have to actually add position to this. So I'm going to pull out position, and it's just going to hang over here for a second. So we have these 3 sections right here. Now we actually need to add all of these together. So the first thing I'm going to do is pull out an addition, and I'm going to drop position in, and velocity and time in. And then I'm going to pull out another addition, and I'm going to drop this whole thing in to that side, and this whole thing in to this side. So we have this equation here. And that is, you can kind of see how the lines are outlined there. This is how you want your equation to look. And again, if you don't get this, I'm going to share it. It'll be online. You don't have to worry too much about it. It's not a problem. It'll be available to you. And I hope that you guys take this code and use it in your games. This is what remixing is all about. Take my code, use it in other games, make it better. It's going to be a lot of fun. The variables you can change to make things do different, jump quicker maybe, or fall slower. It's pretty cool. All right, let me zoom out here. And we're going to take this whole equation, and when that comes in, we're going to set it to next location. Once we have it set to next location, excuse me, we're going to take it and drop it right below define gravity. We're going to make that function right there. So that's all we're going to do. We're going to say, hey, here's our gravity, here's the equation, set our next location. When we do this equation, we get a location out of it, and we just want to know where our next location is so we can move there. All right. So here's where we use the timer. So the timer's in sensing. And this is pretty cool because there's a lot of stuff we're used to typically taking some sort of sensing. We're looking for colors, we're looking for distance, we're looking to see if maybe a key was pressed. You know, we're waiting for input, but there's more than one place we can take sensing from. Sensing doesn't necessarily have to come from the user of your program. Sensing can also come from the computer. Computers do a lot of different things. And one of the things that it does is a computer has what's called a clock in it. Now, a clock isn't like we traditionally think of it as being on the wall. I used to have them back here, but being on the wall and ticking away all the seconds. A clock in a computer is just a rhythmic way that the computer processes information. So it processes, doesn't process, doesn't process. But it knows that in between each time it processes something, that it's so many probably, what is it down to now? Microseconds, milliseconds. We measure most on milliseconds now, but it's very, very, very quick. It might even be down to picoseconds. So we're going to use the clock, and one of the things we have available to us is a reset timer. So what this does is it says there's a timer always running in Scratch, and it's watching the clock of the computer. And what we do is tell it to set it to 0. So first thing we're going to do is reset timer. We want our clock to start at 0 when we press the space key. The way this equation works is wherever you're at, 0 is the time when you start to jump. It may not be the time and how you're playing the game or how long it's been playing the game, but it is the time on when you start to jump. You guys are pretty quiet. If you have any questions, again, feel free to say something. I am watching. All right. The next thing I'm going to do is I know that in this equation, just because I took physics, I know that the equation is an arc. So it's going to go up, it's going to hit a top, and it's going to come back down. This equation goes from positive velocity to negative velocity, meaning that we always know it's going to shoot up and we always know it's going to come down. So I wanted to stop solving this equation when we get back down to where we started. And this, or back down to the bottom, that is. So I know that we started 100 or negative 130, excuse me. I don't want us to drop below 130. So I'm going to use the repeat until. And I want to repeat this equation until I've reached negative 130 again. Now here's a trick with computer science, is that we don't want to know when we hit 130. The likelihood that we're solving this equation and 130 comes out exactly is very, very, very small. Very small, because there's a lot that can go on. And you'll see this equation is going to get a little more complicated. There's a ton that it can go on. We're probably never going to hit 130. Most likely we're going to hit 130.2 or 131, or we're going to hit somewhere around it, but we're never going to hit on 130. So we don't want to check and see when it's equal to. What we want to do is, since we're falling, we want to check and see when we fall slightly below it, and then we're going to move them back up. And with that, we're going to look at the Y position. The Y position, oops, wrong space. The Y position is what's important to us here. And I'm going to go into operators, and I am going to pick this less than sign here. Now I want to know when the y position is less than negative 130. Again, don't do equal to. You can do equal to or less than, but we don't need that in here. Just less than is perfectly okay. It makes life a lot easier. And we're going to drop that in. We want to repeat until we fall just below 130. And then what I was saying is when we fall below 130, we don't want to stay below 130. That's kind of a pain. So what we're going to do is we're going to set y to negative 130 after that's all done. Okay, so that'll let us go up, it'll let us come back down, it will go right below it, but when it sees that we're right below it, it's going to pop us right back up so it looks like we're standing on top. And this is important because if you think about a game like Super Smash Brothers, when you jump and land, this is doing the same equations. This sort of thing, they do a lot more complicated ones, but this sort of thing is called collision detection. And I just gave it an arbitrary, even though it's not colliding with anything, I gave it an arbitrary place to collide with. And this is how we kind of do collision detection. We see if we've moved over the space, and if we have by a pixel or two, we move it back. And this is important because when you see Mario land in Super Smash Brothers, it doesn't look like his feet sink into the ground. It looks like his feet are standing right above the ground. But what we don't see is there's a very, very small millisecond where he sinks below and pops back up. So everybody does this. It's just in some of those nice games, it's a lot harder to see. In fact, nearly impossible to see because the coding's really, really good in it, and the game's processed super fast. All right, now we're at a good spot where I'm actually going to go to my blocks, and I'm going to drag gravity into this. I want gravity to start calculating here. Now there's two things it needs to use that we're going to grab from our variable setup. And there's one that I'm going to input right now. And the one I'm going to input is velocity. And I'm just going to set it to 10, I think. I'm not sure. It seems like a good one. We'll try it out. The next one is I'm going to go back to sensing. And I'm going to grab my timer variable since I reset the timer. This is important to drop in, because time is a big piece of our equation. And the last thing I need is my y location. So I'm going to take my y position and drag that in as well. Now let's see if I've done something right here. Did one thing wrong that I'm seeing, is I forgot to move him. So I need to set my y location. I'm setting my next location. I need to set my y location, not change, but set. Because the equation's doing the change for me and adding it to my previous location. So I need to make sure I set it. We could use a change in here if we wanted to, but we'd have to change the equation just slightly. And I am going to set that to my variable next location. All right, now let's give it a shot here. There he goes. So you see how at the very bottom, he kind of falls just a little bit and then pops back up. It's very hard to see. In fact, if you watch the number down here, you'll see it better. Just barely. It's hard to see, especially with this one. It went to 130.9 was the next location. So you can see where its next location is supposed to be. This is pretty cool. This shows you how that physics equation is working. All right, so this is boring to me. If we think about Mario, think about even the old Mario games. Think about Super Smash Brothers. When you jump, it doesn't jump slowly. It doesn't do this. Look how slow he's going up and slow he's coming down. And you'll notice that the velocity slows as he gets to the top and then speeds back up as it comes back down. This is not how our games work. And the reason this is because the way gravity works in real life is that our fastest acceleration is right when we take off from the ground. That's when we're moving the quickest. And as we go up, we're slowing down. Your guy's not doing it? That's okay. I'll share my code, and your guy might do it here. Go ahead and look through this too. It's this equation is kind of complicated to write out, and make sure you get the blocks in the right order. If you do the wrong order, the math might not go well. And remember to set the Y location to next location. That's a big one. But anyway, so yeah, this is how gravity works. This is a very good representation of gravity. Video games, this would be no fun. We would not be able to jump over a lot of stuff if this was how most video games worked. Typically, how video games work is you have this like super fast acceleration right at the beginning, and then you kind of slow at the top. And then as you fall, you actually fall at a pretty consistent speed. Sometimes you speed up, but not a lot. Most of your energy has been depleted by the time you hit the top. And it doesn't gain energy as you're going back down. It defies physics. We call it physics, but it's not true physics, especially in Super Smash Brothers. You play Jigglypuff. Jigglypuff is very, very light of a character. He's rated at like a 0.4 gravity. I mean, he floats down really slow. Samus is even lower than that. They purposefully defy physics because of their character types. So we want to create that. Let's create that. This is no fun. It's entertaining, but not fun for a game. So we're going to change some stuff. One of the things we're going to do is I'm actually going to alter what velocity it's moving at as it continues through its jump. First off, we're going to launch him. He's going to jump quick. We have 10. If I set it to 100 right now and do this, he's not going to come back down for a while. Yeah, he'll sit up there for a while. 100 is taking off really, really quick. And it's doing, you see that equation still going. Now he's starting to fall. And this is going to fall for a couple more seconds here. So we want to launch him right off the bat. In fact, earlier when I was playing with this, I had a velocity of actually 300 as the launching speed. And I'll show you what we do to get that fun launch out of him too. All right, let me compare my code here, make sure I have my stuff right. Okay. So the first thing I'm going to do to get this going is I'm going to change my gravity function here. Calculating gravity is fun, but it could be more fun. Defying the rules of physics is always fun. So what I'm going to do is I'm actually going to track my velocity, and I'm going to change my velocity throughout the jump, as I said. So I need to figure out how to do this. And the way I'm going to do this is by trying to adjust it until I reach the lowest point possible. And this just takes some playing, to be perfectly honest, and deciding how to do these equations. There might be a better way. So what I did is I'm going to look at my current velocity, and if it's greater than a certain number, I'm actually going to change my current velocity. I'm going to divide it by some other number. And we could probably come up with some crazy equations to adjust the velocity that might make it really fun. I use divide. It's just something, I just threw it out there. It seemed like a good idea. All right, so let's say I was saying that I'm going to find when it's finally, while it's greater than a certain number, and this number that I picked was 0.04. and then I'm going to find in my variables current velocity. And I'm going to plug this into my if-then statement. Never mind, you got it. Sorry, I wasn't paying attention to that. Nice job. I'm glad you got it. Me talking way too long about physics and science, let you have some time. I like that. I could talk about physics all day long. I would love to teach physics. It would be a lot of fun, especially if we could do stuff like this in physics, make it lots of fun. All right, so I want to do something as long as it's greater than 0.04, excuse me. And what I want to do is I want to set my current velocity to an equation. And this is where I'm going to take my current velocity and I'm going to divide it by, what did I decide? I decided 1.3 for this, I think. All right. So every time I come around here, I'm going to check and see what my velocity is. And I want to adjust my velocity. And then I'm going to attach my equation back on there. Okay. Now up here, I'm not doing anything with current velocity. So you notice that I'm changing my current velocity, but I want the velocity to come back in here. But I'm never changing it. So I need to add it in up here. Let's see, I am going to do this here. I'm going to just take my variable, I'm going to drop current velocity where that 100 was. That's our velocity, that third one, right? Now there's one problem with this right now, is that I never actually state what my original velocity should be. Because I had 100 in there, that was fine. I need to initialize this. So I'm going to take set current velocity, I'm going to drag it above the repeat until, and I'm going to change this to 300. Now let me make sure I got my code right. Yeah, so now let's try it. I'm going to start this again. Let's check that out. This is a lot more fun. So he quickly jumps, but then slows and kind of floats down. Doesn't really fall, but it's more of a consistent float. And you'll see that my velocity starts off at 300, but by the time I land, my velocity is 0.03. I know, streaming uses so much resources. That's okay. So look at that. That's a lot of fun. And what's great about this is we get this cool jump arc too as we go side to side if we use the A and D keys. And you guys might not have that unless you copied my code yet, but it is available. I'm going to save it right now. You can actually go in and you can get this code. And look at that. We got a cat that jumps a lot nicer. Now let's play with this though. Let's figure out what these different things do. So I'm going to change down here the current velocity divided by, and play with this. Add a different equation into it. Try to break it. See what happens. I want to see what you guys can do. So I'm going to change it to 2. I'm going to stop the program, restart it, and you'll notice, oh, when I divide it by 2, look how quickly he hits 0.03. That is very, very quick. He goes from 300 to 0.03 almost instantly. And that's because each time we come around, we're dividing it by 2. So let's go, and we had 1.3 was our original. Let's go 1.1. Let's see what that does. Let's go the other direction. Now if we stop and start again, now we got another problem. He like launches way too high. So that's how I started playing with this. Now we can do this all sorts of ways. There's all sorts of fun stuff we can do. You could subtract a certain amount of velocity each time. You could do subtraction times some number from current velocity. You know, like subtract 3 or take 3 and multiply it by, you know, some random number and subtract it, or or add a number to current velocity and then divide it out. Think up equations. There's all sorts of fun stuff that we can do. Is 1.2 cool? Let's try 1.2. Oh, is that the one that just launches them? Yeah, 1.2 just skyrockets him. But check this out. If we take 1.2 and we change our starting velocity to 200, and we'll restart it here, he actually kind of does the same as 1.3 and 300. So for every 100 here, to get the same behavior, you could change the 0.2 to 0.3. Let's see, I bet you if we did 400 and changed it to 1.4, we might get some similar behavior. Look at that, it's almost exactly the same. So if we start dropping below, that's when we get some crazy behavior. Oh, see now like 400 and 1.3 is really high, but it doesn't go off of the screen. Let's see, let's try 600 and let's keep it at 1.3. It'll probably go off the screen. Yeah, it goes off the screen. Not for very long. So let's try 600 and 1.4. I bet you we get about the same. See, it's a little bit higher, not quite as high as 400 and 1.3. But see, it just kind of floats down. That's what I like about this. Quick jump that floats down. So that's creating some gravity. We messed with gravity a lot. This is game gravity. This is not real life gravity. This is not tossing a ball in the air. It's a lot more malleable, and we can definitely make it. We can make games with gravity. It's extremely important to games when we're jumping up over things. Objects are coming at us. Maybe we're trying to jump out of the way. We're playing like Mario, where you're running sideways and you come across a Goomba and you got to jump over him or jump on him. The way that gravity behaves is going to make the game either easier or harder. So you can use these equations to adjust your gravity to try to make a game easier or harder for your people to play. And the way to think about this is maybe our first level we create, we go in and we make the gravity super simple. It's very, we know where we're going to land. We always know where we're going to land. So for example, I like Mario Odyssey that came out for the Switch. And in Mario Odyssey, most of the game is spent on their little planet Earth, and they are gravity seems to behave fairly normal. However, normal for Mario. However, there's a certain part where you get to the end where you get to a spot in the game where you end up on a planet, or if you think about, or a different planet, if you actually super double jump, that's a little bit harder. So with double jump, and I'll get to that in a second, that's a good call. But how we can make our second level harder is maybe we make it seem more like we're on the moon, or on a planet where maybe we went to a planet that's 2 times larger than it's 2 times larger than Earth. We would take this and we would actually change this, instead of 4.9, we would change this to 9.8, which would be relatively 2 times larger. And now our jump doesn't quite behave the same. It's a little bit different. Not by much, but just a little bit different. It's probably because of our 600 and 1.4 in here. If we adjusted those back down, it would have more of an impact. So double jump. Double jump is a little bit harder. And the reason being is that we have to do an interrupt here. And I'm not fully prepared to show that today because that's a little bit more code. But what we do with double jump is because we have this repeat until, we can actually tell it to repeat until, or we can let an interrupt come in and let it kick out. So what we would do, maybe I could do this quickly. Let's see. So we would do, hold on, I'm thinking of the best way to do this. Let me look at my sensing here. I don't know if this will work very well, but let's see. So double jump is tough because we don't want to create a jump that we can continually jump. We don't want 1, 2, 3, 4, 5 jumps, That doesn't make a game very fun. If we create an infinite amount of jumps, we would always stay away from the bad guys. There would be no challenge. So you actually have to keep track of the quantity of times you jumped and then keep track of when it stopped calculating. So this is a little bit harder. I'm going to see if we can create an infinite amount of jumps here. And I wonder if we can do it just with this here. So we can look for the positions changed or the space key is pressed. Let's see if this will work. No, that's not going to work because it knows the space key just got pressed. This creates what's called a race condition. It's trying to turn the space key negative, but it's already positive here by the time it hits this. So that's not going to work either. It was worth a shot. I didn't think so, but again, worth a shot. Let's see. Good question. Double jump. I honestly think if I was going to do double jump, I wouldn't build gravity. I would build this gravity like this, but I wouldn't build this up here like this. I would have actually built this more into this down here and made it a little more complicated. Let's see. I'm trying to come up with some other ideas here for double jump. Without taking another hour to do it. I don't know. Let me work on that one. I will. I'll keep working on that, and I'll also talk to Tyler. He's our kind of our resident game teacher. He's really good at games. He and I develop games together. Just in general, we like to develop games together. So, and not just video games. We're developing a board game together too. So let me talk to him about it and see if he has any ideas of how we could build it into this code. I would definitely have to think a little bit more. But I bet you anything, Tyler already has something built. And hey, if you did make a game, awesome. Share it in the chat here. You can share the link, and other people can click on it. And yeah, let's check it out. I would be more than happy to show your game off. Because we got about 9 more minutes. I might call it early if nobody has any questions. It's kind of quiet tonight. Last Thursday we had quite a few people on actually. It's pretty cool. And actually, I don't know if anybody's interested, but I'm actually trying to get Tyler to. He wants to make a Pokemon game inside Scratch, like the old Pokemon, like traditional Pokemon. And I'm hoping that maybe this Thursday at the same time, 7 p.m., I'm hoping that he would be willing to come and start his Pokemon game. on Scratch and start making it. And if you guys want to watch him do that and watch how he puts things together and listen to him explain it while he does it, I'm really, really pushing for him to do that. He hasn't let me know yet, but if you guys watch Twitter, if you guys watch Twitter, I'll say whether or not he'll be doing it. And you don't have to log into Twitter. I don't think so. Maybe you do. Let's see. I don't know if our Twitter shows. Eventually, I'm going to have Twitter show on our website too. But that is coming up. Yeah, if we just go. Yeah, okay, you don't actually have to log into Twitter. Oh, you did it on a desktop version? Okay. So what you can do is, are you logged into your account right now uh, on the web version? Because if you are, you go over, start a new project, and go over to File, and you click Load from your computer, and that will bring up a browser here. And I don't know if you have Mac or PC, so the browser will look a little bit different. I'm on Mac here. And you find the file, and you can load it in, and it will load into Scratch. Hopefully it all works the same and looks good. Scratch 3.0 is a little bit buggy. But here's our Twitter, too. You can actually just click on that. So it's just twitter.com, future code. You don't have to log in. You don't have to create an account. But you can go there, and you can see our updates. And if you guys actually have questions, I don't know how many of you have Twitter. Some of you are a little young for Twitter. Some of you shouldn't be on it. The internet is crazy, to say the least. But if you do have Twitter and you want, or if your parents want to, you can actually tweet at us. You can get your parents to get an account. You can tweet at us questions. And me and a couple other, yeah, you shouldn't have Twitter. You're only 10. You don't need that junk in your life. But talk to your parents. And if you guys want, you can, your parents and you can tweet questions at us. And Twitter is actually watched by me and a couple other teachers. So we will respond to you guys. We used to have a different Twitter where we responded to people, but we changed it when we officially got our name. The organization, we changed it to match our name, and when we did that, we just signed up for a whole new one because we have new email addresses and all this fancy stuff. So we do watch it. It doesn't look very active, but we're there. We're watching. If you guys have questions, you can always let us know on there. All right. So what do you guys think? JT, you've been pretty active today. Pacific Coasters, I'm not sure if you're still on. It doesn't tell me who's online. It just tells me how many viewers there are, which is pretty minimal tonight. But did you guys think this was okay? Was this helpful? Give you some ideas? Hopefully, if you go in and use my code, hopefully you'll get a couple, a couple pieces of code that you can use in your own game that will help you create a much cooler system. Yeah, work for you guys? Okay. Cool. I'm happy. This was fun. Thanks, buddy. At least someone thinks I'm cool. Don't go convince my wife that I'm cool too. Tell her that I'm cool. She's at one of our classes right now. She's a teacher and she helps teach us how to teach because I'm not a teacher. I am a computer scientist. So I type code all day long. I don't teach all day long. She gets to teach all day long, so she helps us be better people, which is good. We need that. All of us need practice. Um, so she's out at a class. Tyler's at a class too. Again, uh, check out Thursday. Hopefully Thursday. I want him to do the Pokemon thing. I think that would be awesome. We've been talking about it for like. I'm not a big Pokemon fan. I didn't grow up with Pokemon. I'm a Zelda fan, as you might be able to see. It's probably too low, but Zelda. Um, I'm a Zelda fan. He's a Pokemon fan. We were talking about creating the Pokemon in there and throwing around ideas, and we're both really, really excited and think that we could create a cool Pokemon game inside Scratch. Um, we've created other cool games, and Scratch is super powerful. We think it would be fun. So check out Thursday. If he's not doing it on Thursday, probably I don't think it'll be me, but I think that Jonathan or JD, everybody calls him JD. He's one of our other teachers. JD will probably be on here, and he'll be teaching. So he's definitely he's a good teacher too. He's actually an electrical engineer, but he really does well with Scratch. And I'm not sure what he's thinking about teaching this week. I got to reach out to him and see. But if you again go to that link and look at Future of Code, I will make sure to post what he's going to be doing. And I probably won't post who's going to be teaching what until, oh, you're Jonathan too. JD would like that. Um, we have quite a few Jonathans that actually work for us, so that's why he's named JD, so we know the difference between the Jonathans. Um, but yeah, if you look, I would say I'll probably have it posted by lunchtime, so like noon-ish on Thursday, what we're gonna do. And if not, just come back at 7 on Thursday, and you can check out and be surprised too. All right, guys. Well, I'm gonna call it a night. I'm starting to lose my voice. It's getting scratchy. I've been fighting the sniffles today, so I'm gonna stop talking. And you guys have a good night. Email me. Um, you can email me. You can tweet at me. You can call. Whatever you guys need to do, and let me know if you guys have questions, need help. I'll do my best, and if not, I will find a teacher that can do their best. So, anyway, excuse me. Talk to you later, guys.